Okay, our next talk, we've mentioned distributed systems a lot, and now we're going to try and actually do a distributed system talk. So we have some very brave speakers who work with CERN and who work with, oh, there. My mic is flaking out, so I'll do the best I can. First of all, I'd like to introduce the speaker who's on site, who is Nikos Sipinicus, sorry, Nick, from CERN. And then remotely we have a two-person team, Janos Bonic and Sanja Bonic. Janos is a Red Hat engineer, a principal engineer, and one of the founders of this project. And Sanja is a senior software engineer and also a PhD candidate at TU in Berlin. So they're going to give you an insight into what it was like to build a science lab with ContainerSSH in the production research world. Thank you.
Thank you. So we're going to start with a short video to introduce the project, and then Janos is going to take over remotely and give you an introduction. So let's see if this will actually work. No, apparently not.
ContainerSSH is a free open source SSH server that drops users in containers. Wait, what? Yes, you heard it right. It's not running in a container, it launches containers. Here's how it works. Step 1, the user connects ContainerSSH with their regular SSH client. Step 2, ContainerSSH sends a webhook to an authentication server to check the user's credentials. Step 3, ContainerSSH sends a webhook to the configuration server to fetch the user's configuration. And finally, Step 4, ContainerSSH connects the Kubernetes, Docker or Podman API to create a container and connects it with the SSH connection. That's not all. ContainerSSH can record a detailed audit log, act as an SSH proxy and much more. Check out the detailed user's guide on containerssh.io. Do you want to see a demo? Here we go. SSH foo at localhost on port 2222 with the password bar, and we are inside a container. No network interfaces, no other processes visible, it's only you. And in containers, no one can hear you scream.
So Janos will present the basic idea behind the project and the general overview, and I will then present my use case, our use case at CERN, and how we are planning to develop it.
So today's topic is building a science lab with ContainerSSH, and one of the topics that we found out was a really good use case for this project. We've seen the video. So the question is, what is ContainerSSH? You've just seen a little bit of it. You have gotten a little bit of a taste for it. But basically, ContainerSSH is an SSH server. And if someone connects, it starts a container. And there are no system users involved. So this entire project is about piping the SSH connection directly into a container API without needing to create system users. And as you will see later in the presentation, that is quite a big deal if you have thousands and thousands of users. ContainerSSH itself does not run in a container. It can, but it doesn't have to. So you can run it on your host, and then you can connect to the Docker or Kubernetes APIs or as you wish. And the important bit is, as I said, you don't need system users. You can configure it dynamically. That means you can give each user their own individual container. You can configure them to mount volumes and all those kinds of things. But first.
So we have created a community around this in order to make it as open source and contributable as possible. We have started this project, I think, around 2 years ago. It has over 1,000 GitHub stars by now, 30,000 lines of code and more. It's well tested. It has a Slack community, so if you like to join and listen in, start asking questions, there's a Slack link on the website, ContainerSSH.io, in the footer. We also have a working group with a charter where you can see how voting works and how all that stuff works. You can join as well. And we've also already given several talks at conferences like FOSDEM, DevConf, and others. There's a few articles written about it, and we're also using it in university projects for example, for master's theses and various projects.
So let's take a look at ContainerSSH itself. Here it is, and somebody connects. What's happening? Well, we give them a container and we drop them inside. And if the user disconnects, then the container is gone. So this is the basic premise that whenever a user disconnects, the container will be deleted. If they left any files lying around, except for volume amounts, then their container is gone. And this solves one of the big problems of having bastion hosts or jump hosts or any sort of shared environments where people just leave stuff lying around even though they don't intend to, and it fills up the disk and you need to regularly clean it up and all those kind of problems. Now, if two users connect, they get two separate containers. That is not really surprising. That is the whole intention. Each user gets their own container. So if they run something that is a little bit more sensitive, then they're at least isolated on that level. Now, what happens if one user opens two connections? In this case, ContainerSSH currently opens two containers. So each connection goes in their own container, and this might be a little bit confusing to users that they don't see their things that they're running in the other container. But this is necessary to make ContainerSSH scalable as it currently is. Later on, we might decide to support something where we can synchronize across the cluster and make sure that containers are not deleted, that are still being used. But right now, the priority is that you can run multiple ContainerSSH instances for failover, for scalability, and all those kinds of things. Now, ContainerSSH in its default behavior, and as we will explain, this is the default behavior that is the currently released version, does something where it calls out to an authentication and configuration server. The authentication server is responsible for checking the user's credentials. So if you're using the currently released version, that's either username and password or username and SSH key. As Nikos will explain, he did a great amount of work in implementing Kerberos support, and we're currently also working on OAuth support, which I believe is unique, as we're probably the only SSH server that properly will support OAuth as a first-party mechanism without any sort of special client. Now, the other server that you can set up is a config server. The config server lets you give dynamic configuration for creating the container, for security settings, and those kinds of things. So, for example, you can give each user their own container, or you can give each user their dynamic resource constraints, or you can mount their own volume off of a shared drive. So, for example, you can mount a volume off of an NFS server dynamically as you configure it from the config server. And these are all, anything that is not related to authentication is dynamically configurable, so you just need a tiny bit of a webhook server, and then you can pass back the configuration to ContainerSSH. So why would you use ContainerSSH over something more traditional like OpenSSH? Well, one is the ease of access. If you don't have to set up users, if you don't have to do all those things that are typically associated with a traditional Linux or Unix-based SSH server, it gets much easier to scale SSH service. The other main benefit is that we have a container engine, and the container engine allows you to set up a resource-constrained environment. So you can limit memory, and not just in the way that you would usually set up view limits that are for one process, but you can set up a resource limit for the entire environment. You can set up, so as I mentioned before, the automatic cleanup is also something that you might be interested in. But if you're concerned about security, you can also record a detailed audit log. I'll show you later in the demo that the audit log itself is currently not real-time, but you can make it real-time with slight code modification. So it's really interesting to use it for other projects as well, such as a current research project that a few students have finished just a few weeks ago, watching what attackers do when they're presented with a vulnerable SSH server. And as Sanja already mentioned, it's fully open source. Where can you get it? ContainerSSH.io. You can go to the Slack link and join the chat and ask questions there, or you can go to github.com/containerssh to get the source code. This is the part where Nikos would normally jump in. I'll try to summarize as best as I understood what the work that he did there. He would be able to go into much more detail into this. Most of this work was done by Nikos. So Nikos has a public Linux login user service, which is used by people to log into remote servers. They're using it for all kinds of work that they're doing. And during the pandemic, it developed that people even used it for writing code remotely. So basically, this is something where people would use editors like VS Code and then remotely log in or directly SSH into a remote server and develop there. The problem with that is that things like language servers, etc., are not concerned with security on localhost. So if you let people into an SSH service where other users are present as well, there is a possibility of stealing credentials or accessing services that don't belong to you, and those kinds of problems. As you can see on the slide, there are about 100 VMs and about 2,000 logged in users at any moment. And ContainerSSH was run as a pilot service, and users were actively accessing the service. You could choose to access this. And thankfully, Nikos has spent considerable amounts of time integrating Active Directory and Kerberos. And the reason why Kerberos was needed is because users of the LxPlus service were expecting to be able to mount their own home directory, and they did that with Kerberos tickets. So they would log into Kerberos on their own laptop and then use the Kerberos ticket to mount their volume or do other things as well inside the container. So that entire integration was developed thanks to Nikos. And this is something that's going to come out in the next release, which we're really hoping to finish up by the end of the year. As I mentioned, the privilege escalation vulnerabilities can be quite common, so containers don't entirely mitigate that, but they can somewhat mitigate them. You could, of course, go the directory of the direction of running micro VMs as well. Again, shared resources like network interfaces and /TMP are a problem, as well as the resource usage on the SSH server. So containerization helps all those problems. So Kerberos authentication, as I mentioned, works as follows. Instead of having the authentication server, the authentication is done by Kerberos, and then you have an authorization webhook, which checks if the user is actually allowed to access the service based on the Kerberos ticket, and then comes the configuration server as normal, and then we have what was already described as starting the container and mounting the NFS share. So the last question that we have is where is the future of ContainerSSH? In the last little bit more than a year, we've been working on overhauling the core engine, because ContainerSSH itself was developed as a smaller project, and then it got bigger quite quickly. And we are hoping to finish up the current release containing the new authentication features by the end of the year. One of the features is OAuth 2 and OIDC support. So if you're using a Keycloak or anything like that, then this would be something that could be interesting for you. But I'm going to demo this with GitHub login. So you could also just have people log in with their GitHub credentials. And now it is the demo time. And if you have a laptop in front of you and a GitHub account, then you might want to participate. I'm going to switch over to my console. And I'm also going to open, hold on, let me stop the slides here. So I have my real-time logs here. And as you can see, if I log in here, I click this link, and there's the wonderful GitHub authentication screen. I'm going to get a warning because GitHub doesn't like the device authentication if you're using it for a server. Now I can authorize ContainerSSH. And once the container started, there I'm logged in. Now if I look at my real-time logs here, oh look, a console. If I start typing here in real time, I can see my console on the right side. And if you want, you can also now hold on, let me make this a little bigger. If you do this, you have to use port 80. That was the only port that we had open on the research server. If you do this, then you will land on this SSH server with your GitHub user. I'm just gonna give it one more minute. And this should also be visible. I'm just going to switch for a second here. So once Sanja is logged in, there should be a second console here. But give you folks a few minutes to try this for yourselves. And let's hope that this is not one of those demos that are going to break due to the connection being a problem. And you can see that there's a second console. Sanja has already logged in. And if anyone from the audience wants to log in as well, then you can send a message to the conference as well. And Sanja is asking me to zoom in, but actually she should just make her terminal a little smaller because that would be reflected as well, since the SSH connection translates how big the terminal is. So you can see that the terminal resizes. Oh, now she made it too big and it's dropped below. But you can see in real time as Sanja is resizing her console. So that's the level of audit logging that you can do with ContainerSSH. And it's down there. Oh, we have somebody else as well. Okay, let's see what this anonymous person is trying to hack here. By the way, you can use that. There's a command line utility that you can use. Nice try. Nice try deleting root file system. It won't work because it's a container and it has a read-only root file system. Try the GH command line utility though. You can do stuff like, if I'm going to open this here, GH repo list. Because you logged in with GitHub, your GitHub token is automatically here, and you will be able to see. So try GH repo list. You can see your repositories here. Repo space list. Wow, that's a lot of people logging in. By the way, I'll show you in the slide how to revoke your access token later, but I will also wipe this integration entirely, so your audit logs and everything else will be gone. There we go. Someone named Ondrek. Hi, Ondrek. How are you doing? Anyway, I'll leave this up for a few more minutes. Let me know if you can break it, because if you can, that would be awesome. In the meantime, let's go to the official part of please do wipe your access token once you've finished. Go to github.com/settings/applications, click on authorized OAuth apps, and revoke the ContainerSSH demo application access token. And I believe that is just the right time for having some questions.
I love that the moment you try to make a demo, everyone tries to break it. That's just beautiful.
So Janos and Sanja, thank you very much for continuing with the talk and the demo. The number one question is, Nico's okay? The answer is yes. He's being taken care of by the health professional we have here. Hopefully no major issue, but he's awake and talking. So there's a couple of questions, at least in the version that I'm looking at here, which I hope is up to date. One is a question of whether you can use the mobile shell instead of SSH to overcome intermittent connections.
We looked at mobile shell, so that's a protocol called MOSH. The way that it works, as far as I remember, is that it opens a separate connection apart from SSH, and that's how it deals with intermittent connections. We looked at it. It's possible to implement, but we haven't done so yet because it requires quite a deep integration on our side to make sure that it works inside the container. The biggest problem of it is that we give you the ability in ContainerSSH to run the container entirely in a network disconnected environment. And that is something that MOSH doesn't have a good time dealing with, so we will need to implement it into the ContainerSSH agent that's running inside the container, as well as into ContainerSSH itself. It's possible. If we get a lot of time or a lot of contributors, then we'll look into it. But right now, it is not possible.
Sounds like an excellent graduate student project. Okay, and another question. do the SE Linux constraints make sense in this environment? Or can we have similar functionality just thanks to the container itself?
So SE Linux and the container environment are not mutually exclusive. So for example, I'm running on Ubuntu. That would be AppArmor. If you're running on an SE Linux system, the SE Linux labels would apply just as if you were to start a normal container. So don't think of this as something magical. If you do Docker run or Podman run or kubectl run, that's exactly what ContainerSSH does. The only difference is that it starts an agent inside, and sometimes it uses, instead of run, it uses exec to handle multiple channels inside the same connection. But it is the exact same thing as if you were to start a container normally. Don't think of this as some super advanced technology in the sense that we didn't reinvent containers, we're just using what's there.
Okay, thank you very much. That's all the questions that were submitted. If anyone wants to reach out to you online, there's OpenSSH web pages and contact information there. Appreciate your participating in the distributed demo.
Thank you very much, and thank you for not disappointing trying to hack the server.
Thank you, and don't get too hot. Have a nice lunch. Bye.
Bye-bye. So quick housekeeping announcements. The speakers are available for more questions, obviously, except for the remote speakers and Nikos. Lunch is going to be served at your table, so make sure you have your nameplate out because your nameplate shows people what lunch you ordered. So if you haven't folded it up and put it in front of you, please do that. After lunch, there will be a barista here making more coffee. So come early, get your coffee in the main hall. And if you're interested in some of the local education activities, that's what the posters are on either side here. So please feel free to look at those and access those websites or those URLs. And that's the last housekeeping. So have a good lunch, and please be back here on time promptly for the afternoon speakers.